Hi everyone, welcome to my channel. In this lessons, we will learn different operation of matrices like transpose, determinant, adjoint and inverse. So we will begin with the examples of 2 by 2 matrices follows 3 by 3 matrices. Let's begin with transpose. Now in transpose, what you do is transpose means interchanging rows and columns. So the rows becomes columns and columns becomes rows. So in this case, this is a 2 by 2 matrix. Why? Because it has two rows, row 1 and row 2, and two columns, column 1 and column 2. So as I mentioned, what will be the transpose for this? Rows turning to column. So 4 and 3 is row 1 and this becomes now column. Right? And then 1 and 2, which is row 2, this becomes column. So this is a transpose for the matrix. So this is in simplest form the transpose of a matrix. Now let's work on another operation, which is determinant. So how to find the determinant of a matrix? For example, if you have this 2 by 2 matrix, the determinant will be multiplication of these diagonal elements A and D and subtracting them from opposite diagonal elements, which is B and C product. So AD minus B and C is the determinant of this 2 by 2 matrix. Let us now work with an example. So in this case, what will be the determinant? You multiply by 2 by 2 and then you subtract it with the opposite elements product, which is minus 1 times 4. So if you multiply minus 1 times 4, it's actually minus 4, and then 2 times 2 is 4. So negative and negative, they are multiplied, becomes positive, right? And therefore the sum is 8. So the determinant, which is usually given by the straight line, corresponds to this 2 by 2 matrix is 8. Let us now work for 3 by 3 matrix. So in 3 by 3 matrix, there are a couple of things you need to know. Now let's begin with the first element corresponds to A11. So the formula is, it will be minus 1 to the power, the first row element and first column element, so sum of 1 plus 1 times A11 element times the elements other than row 1 and column 1. So this is row 1, A11, A12, A13, and this is column 1. So what are the elements left other than this? It will be A22, A23, then 3-2 and 3-3. Okay, now let's move forward for A12. So again, it will be the same element A12 times minus 1 to the power sum of 1 and 2, and then it will be determinant of elements other than row 1 and column 2. So other than row 1 and column 2. So as you know, row 1 is A11, A12, A13, and then column 2 is A12, A22, A32. So other than that, you're left with A21, A23, and then A31 and A33. And similarly, moving forward to A13 element. So this will be this, multiply by minus 1 to the power 1, 3, and just eliminate the elements of row 1 and column 3. So you are left with this. Right? So it will be A21, A22, 31 and 32. And now this is 2 by 2 determinant and we already know how to solve it. So what you have to do is you have to multiply these elements and subtract it with this product of these two elements. So solving this will help in finding the determinant for 3 by 3 matrix. Now let us solve using an example. So let's solve for this example. So how to find the determinant of this 3 by 3 matrix, right? Because there are 3 rows and 3 columns. So the first thing is minus 1 to the power, again it's A11 element, so it will be 1 plus 1 times what is the element corresponds to this first row and first column, it's this 1 times, you have to find the determinant for the elements other than row 1 and column 1. So if you eliminate this and this one, so you left with 3, 0, 1 and 0. Let's work on the other one. So this will be minus 1 to the power 1 plus 2 times, what will be A12? It's this 2 times the elements other than row 1 and column 2. So if you eliminate row 1 and column 2, you are left with minus 1, 0 and 4 and 0. Then again plus minus 1 to the power 1 plus 3, because this is row 1, 3, row 1 and column 3, so it will be times 4, and then again you need to find the determinant for elements other than row 1 and column 3. So this will be minus 1, 3 and 4 and 1. And now you have to find the determinant for these matrices. So again, when you do that, 3 times 0 minus 1 time 0 times anything multiplied by 1 will be the same number. So it will be the same. And then what is minus 1 to the power? 1 plus 1 is 2. So this will be minus 1 square. That means minus 1 is multiplying by 2 times and the signs get cancelled. So this will be 1 time this, because the pair signs get cancelled. So this term will be 0. Why? Because if you take the product of 0, it's actually 0, and 1 times 0 is 0. Now let's solve this matrix, this portion of this determinant. So this is minus 1 to the power 3, which means that minus 1 multiplies by 3 times. So you can cancel these two pair, but there is one negative sign left. So this becomes minus 1 times 2 times, when you multiply this, minus 1 times 0 is 0. Again 4 times 0 is 0. So the product is 0, corresponds to these elements. Now let us solve the third part. So minus 1 to the power 4. Again it has 4 minus 1 values which get cancelled. So this will be 1 time 4 times, again you multiply these elements. So minus 1 times 1 is minus 1. And then you have to subtract this from 4 times 3, which is 12. Now negative and negative becomes positive. 12 plus 1 is 13, and you have 12 largest numbers, so it will be minus 13, and this will be multiplied by the element 4. So 13 times 4 is 52, and it has a negative sign. So the answer to this is minus 52, because the numbers corresponds to first part is 0 and second part is also 0. Okay, and third part we already solved. So this is how to find the determinant for 3 by 3 matrix. Now let's work on the next operation, which is finding the adjoint of a matrix. The adjoint of a matrix is fine, and before that you need to know how to find the cofactors. So adjoints are finding the cofactors and taking its transpose. So this is cofactors terms, and you have to take the transpose of these cofactors. So the first thing is how to find the cofactors corresponds to this matrix. Let's begin with the first cofactor A11. So the answer to that will be, it will be minus 1 to the power these elements, which is sum of 1 and 1 element, 1 plus 1, row 1 and column 1, and you have to consider the elements or include here other than the row 1 and column 1. So if you eliminate row 1 and column 1, what element is being left? A22. So you have to find the determinant of the remaining one. Since it's a 2 by 2 matrix, you have only one value here. If this would have been 3 by 3 matrix, you would have find the determinant corresponds to those elements. We will work on that as well. Now going to A12, so A12 means you have to take again minus 1 to the power 1 plus 2 times all the elements other than row 1 and column 2. So which one is it? It's A21. Okay, and then A21 cofactor will be minus 1 to the power 2 plus 1 times again any element other than row 2 and first column. So row 2 and first column, if you delete, you're left with A12. And similarly with A22, it will be minus 1 to the power 2 plus 2 times. Other than these two, you will get A11. So this is how you will find the cofactors. Okay, once you find, you will substitute these values here and then you will interchange. Interchange why? Because you have to find the transpose. So what is a row? A11, A12, this becomes column here. And similarly, A21, A22 becomes column here. Okay, this is the adjoint of 2 by 2 matrix A. Let us now work with an example to understand better. So let's find what is the adjoint of this matrix A, which is 2 by 2 matrix, right? So let's find the cofactor. What is it? It will be minus 1 to the power, again it's 1 plus 1 because it's one row and one column element, times the determinant of the element other than row 1 and column 1. So if you eliminate 2, 1 and 3, it's actually 4. But it's only one element, so it remains the same. You can find determinant on this. Now A12 is what? Minus 1 to the power 1 plus 2 times elements other than row 1 and column 2. So if you eliminate this and this, it left with 1. Make sense? Now going to A21, it's minus 1 to the power 1, 2 plus 1 times, again element other than row 2 and column 1 is 3. Similarly, row 2 and column 2, if you eliminate this, you are left with 2, again times minus 1 to the power 2 plus 2. So minus 1, 1 plus 1 is 2. That means minus 1 is being multiplied by 2 times 4. So negative and negative signs get cancelled and 4 times 1 is 4. So the answer is 4. Again, minus 1 cube means this is minus 1 to the power 3, which means minus 1 is 3 times and you always get a negative sign left. And this times 1. So negative 1 times 1 is negative 1. Then again, minus 1 cube times 3. So this will be negative 1 times 3 is negative 3. And then negative 1 to the power 4, which means it is in pairs, it's a multiple of 2, so negative signs get cancelled and it will be 2. So the elements which you will be getting corresponds to these cofactors is 4, which is capital A11, then what is A12? Minus 1, then what is A21? Minus 3, and then A22 is 2. And now you have to find the transpose to find this adjoint. So what will you get? This row will now become a column. So it will be minus 1, minus 4, sorry, it will be plus 4 and minus 1 here. And this becomes minus 3 and 2. So this minus 3, 2 row becomes column here. So this is adjoint corresponds to this matrix A. Okay, there is actually a shortcut how to find the adjoint without solving these, but it is only applicable for 2 by 2 matrix. And the answer to that will be, what you have to do is, all you have to do is to interchange these two. So 4 comes here, 2 comes here, and then make these two have negative signs. That's it. This is adjoint for this 2 by 2 matrix. So this is just a shortcut without solving these. But this is only applicable for 2 by 2 matrix. So what you have to just do is interchange these two and change the sign of other two elements. That's it. Now let's work on the last example of, so this is all about adjoint. Let's now work on last operation, which is finding the inverse of a matrix. So we already learned how to find determinant. We already know how to find the adjoint, and all we have to do is inverse is 1 divided by determinant of A times adjoint of A. Now let's work on it. So the first thing is finding out the determinant. How to find determinant? Again, you have to multiply. So 2 times 4 minus 1 times 3. So this becomes 4 times 2 is 8. minus 3, which is 5. So you always find an inverse provided determinant of A is non-zero. Since here it's 5, that means you can find the inverse, because 1 divided by 0 is not defined. So that's why this rule is always possible, that a determinant of A should be non-zero to find the inverse. Okay, now let's find adjoint corresponds to this matrix. As I already mentioned, to find the adjoint, what you have to do is just exchange these two elements. So this 4 comes here, 2 comes here, and you have to just take negative sign for those elements. So this will be minus 3 and minus 1. That's it. This is the adjoint, finding adjoint in shortcut form. You don't have to solve it. This is always applicable for 2 by 2 matrix. Okay, and then the inverse is 1 divided by, what is determinant of A? It's 5, and this is the adjoint, which is 4 minus 3 minus 1 and 2. That's it. This is how you find the inverse of matrix A. So I hope you like this video. Please like, share and subscribe, and thank you for watching.